Okay, in this video, I'm going to continue going over factoring, okay? So we're going to do factor by grouping on these next two because that's kind of where we left off before, okay? So in factor by grouping, you do want to get them paired up in a way that the pairs will have something in common, right? So it says rearrange these guys. So let's try maybe doing the RX plus the RZ plus the TX plus the TZ. I know the T's and the plus sign's a little hard to tell. But anyway, let's pair these guys up. Leaving that middle sign just kind of hanging out because it's important that we kind of carry that with our factoring, okay? So get the R out of these, leaving behind the X plus Z. Here's our plus sign. Get the T out of here. Let me kind of make that look a little bit different than a plus and leaving behind the X plus Z, okay? So when these guys left behind match, we're getting somewhere with this factor by grouping. That'll be one of our factors, while the R plus T will be the other. So what we have up next here is another factor by grouping, and we'll pair these guys up, okay? So we'll get the X out of here. I know that showed up capital, but it's supposed to be lowercase, okay? Leaving behind your Y plus 5. Bring your plus sign down. Get your 6 out of there, leaving behind your Y plus 5. And then your final factors will be the Y plus 5 and get the X plus 6 together, okay? The next set here says factor completely. So we'll look for a GCF and then we'll go from there, and you'll get to see how we can see some different varieties of factoring here, okay? So here we've got what's called a trinomial. It's got 3 parts. We always want to look for a GCF to make sure there isn't anything we can get out of all of them, and there isn't in this case. So then we've got to factor this. Now I have a shortcut approach that's going to help us to do this in kind of a organized fashion, okay? So 3 times -1, when you've got that leading coefficient other than 1, 3 times -1, I'm going to put a -3 in the bottom of my X. So I'm going to put my -2 in the top. I'm going to try to come up with two numbers that multiply to give me the bottom while adding to give me the top. Well, the things that will multiply to give you -3 are either -1 and +3 or +1 and -3. And I need for one of those pairs to add to give me -2, okay? And that, of course, would be your 1 and your -3. So we're going to pull those numbers off the sides of our X to begin creating our factors. Because we had that +3 in front and we multiplied initially, now we're going to divide, okay? 1 doesn't divide evenly by 3. Also, the fraction 1/3 doesn't simplify. So here's where we would swing that guy to the front there, giving us 3x plus 1. 3 divided by 3, well, that is 1. So you have x minus 1. So the thing with factoring is you should always be able to take what you get here and multiply back to get what you had. So 3x times x is 3x squared. Minus 3x plus 1x would be -2x, and 1 times -1 is -1, okay? Up here, you've got another trinomial. You want to double check for any sort of GCF that you can get out of everything, but if there isn't any sort of GCF that you can get out of everything, you want to kind of look towards that, breaking it up here into 2 binomials, okay? So you can still kind of do the idea of creating the X here with your -22 and your -9. Of course, a couple things that multiply to give you that while adding to give you that. You'd have to go to your 11 and your 2, and for them to add to give you the -9, you want to stick the negative with the larger number there, okay? What's a little bit squirrely with this is the V's that want to show up here. We just kind of have to work those into our factors, okay? So you'll get your U's here, and then you need to do -11V plus 2V. Because what's going to end up happening there is you will incorporate the V there, and then the V squared on the end. -11V times +2V is -22V squared, okay? So just kind of look out for things like that cause us to kind of tweak our factors a little bit, okay? Up next, we don't have a GCF again. We're going to make our little X here and see if we can factor. Not everything is factorable, right? Like the things that multiply to give you -7 are 1 and -7 or -1 and +7, and none of those add to give you -5. So in that case, it's prime. It's not factorable. Here, this one's a unique situation here. This is what we call a difference of squares, okay? So it's what we like to call a special case of factoring. So it's not a trinomial. We don't have like a GCF, we can get out of there. So in a difference of squares, of course, you're going to have subtraction, hence the word difference, and you've got two perfect squares involved, okay? So if you look it up on a formula chart, look it up on internet, they're going to represent the perfect squares in some fashion like this, where something got squared to give you the first term and something got squared to give you the second term, and you need to identify those things, okay? And these follow like a really predictable formula or pattern, okay? And you'll have the same terms, but you'll have opposite signs in the middle here, okay? So it's our job to identify who's the A, who's the B. In other words, what did we square to get this guy, and what did we square to get that guy? So for us, we've got to identify our A. What did we square to get 16? 4. What did we square to get y squared? Y. So this is our A, right? If we were to take 4y and we were to square it, we would get that 16y squared. Our B, what did we square to get 25? 5. What did we square to get x squared? X. So we've identified our A and our B, and we can follow this formula off to the right here and factor it into 4y plus 5x followed by 4y minus 5x, okay? This right here, you're going to double check, see if you have any a GCF with everything, and I was going to show you, if with large numbers like this, sometimes you may have to go see, like 81, for example. We know it's divisible by 9, but we know 49 is not. 49 is basically it's divisible by 7. It's not going to be divisible by 2. It's not going to be divisible by 3. It's not going to be divisible by 4. So sometimes it's just not a lot of options as to breaking these down really any further than what they are, okay? So when I look at this, I'm just going to kind of play with some numbers here and know that, I may just take a little bit of trial and error, and I can always approach it like I did up here as far as getting that bottom number, getting that top number. But sometimes you can just see, like I'm recognizing the 81 breaking down into 9 and 9, and the 49 breaking down into 7y and 7y, okay? And to get this large middle term, I'm going to go ahead and try it with two subtraction signs in there, okay? So 9x times 9x is 81x squared. 9x times negative 7y, well, the 9 times 7, I'll go ahead and write it out. 9 times 7 is 63, so we're talking about negative 63xy, yx, and then you distribute your negative 7y, I would also get you negative 63xy. And a negative times a negative here, that's a positive 49y squared. So you can kind of work backwards here and see that what I have come up with, and it was just kind of what I saw, it did work out to give me these two factors here, okay? So you can also write that as 9x minus 7y squared. This guy over here, looking for a GCF, not really seeing one, okay? I would go ahead and kind of start breaking it down. That first term is r times r. And then again, I'm seeing a 7 and a 7 here, and maybe those guys can work out to giving me that 14 that we see in the middle. So because he's got a g squared, we're going to have to get a 7g and a 7g. So we've got plus plus. Let's just try this with plus plus, okay? So r times r is r squared, right? R times 7g is 7rg, is 7g times r is 7rg. 7g times 7g would, in fact, give me that 49g squared. So I was kind of seeing the relationship with some of those numbers, and it kind of steered me in the right direction here to be able to factor this guy into these. It's a perfect square trinomial there, okay? Up here, what we have is 196w squared plus 225. So these numbers, these are perfect squares, but when it goes to comes to factoring, there is no such thing. We can't factor a sum of squares, and that's what this is, okay? So it will not factor. We can factor difference of squares. We can't factor a sum of squares. Let's see, can we get a 4 out of everything here? It looks like we can. Let's try to get our 4 out. 56 divided by 4 is 14. 180 divided by 4, if I'm not mistaken, should be 45, right? And then we're going to try to break this trinomial down with our little X looking thing. So there are a couple numbers that will multiply to give me the 45 and add to give me the 14. How about a 9 and a 5? And how about they're both negative? So that we can, a negative times negative is a positive, and negative plus negative will give me that negative 14. So our factors are x minus 9, x minus 5. Alright, I think I'm going to try to finish this in this one video. Okay, so you've got your 45x squared, your 114, and your 72. Okay, so sometimes we've just got to kind of play with what we're working with. There is no GCF in all of these, right? We see a 5 and a 9 and a 15 here. 9, well, we could see a 9. I don't know if 114 is divisible by 9, but I doubt it. Let's see. And it's not. So I'm just going to kind of play with the numbers and see kind of where we're at. Let's try the 9x and the 5x. I'm just going to try a 9 and an 8 with that 72. So that would be 45x squared. And then you got 81x. Then you got 40x. And then you got 72. So 45x squared, excuse me. 81 and 40, let's see what that adds up to. 121, that's not doing it for me. So maybe we could break it down a little bit different. Maybe we could do a 15 and a 3 with the 45. I'm going to come down here. I've got a little bit more room, and I may have to pause this video because it may be getting a little bit too long for me to drag the problem out too much longer. So I'm going to pause this one, and I'll pick up with another video to finish this off.